All right, this is lesson 2.8 in algebra, literal equations and dimensional analysis. I'm going to show you how to do two things here, okay? One is that you need to be able to solve for a specific variable. What I mean by that is this. Sometimes you'll have an equation that looks like this, 4m minus 3n equals 8. And I want you to solve this for n, okay? Or I want you to solve this for m. Right now, if I said solve this equation, there's no one answer here. There's no one specific answer because there's two variables. No matter what I get, when I go m is going to equal, and then n is going to be out there, right? I mean, we're not going to have one specific answer here. So, in this situation, I want you to solve this thing for m. So watch, just watch me do this. What that means is this. When I say solve for m, it means that I want you to get m alone. He's the hermit here. He's the one that he wants to be alone. Okay? So very first thing you do is line down the equal sign. And now here's the deal. You've got to clean the house up and then start chucking people out of the house. Right? Throw them through the wall to the other side. Just get m alone. Right? If it says this, and you're going to solve for m. Okay? So this is what we do. Is the m happy? No, why not? He's not alone. Who's with the m? 3n and a 4. What's the 3n doing to him? Subtracting from him. What's the 4 doing to him? Which one do I deal with first? I'm going to go plus 3n plus 3n. Cross them out. 4m equals 8 plus 3n. Does that make sense? I just simply kicked him out of the house. Right? Now, is the m happy? No, being multiplied by 4. What's the opposite of divide by 4? Sorry, what's the opposite of multiply by 4? Divide by 4, divide by 4. Guess what, people? M equals 8 plus 3n over 4. We're done. You just kick everybody out of the house. That's all you do. And you're done. Did y'all follow that? Well, let's see if you can do one then. Let's just see. Do this. 15 equals 3n plus 6p. And I want you to solve for n. Okay. All right, here we go. Line down the equal sign. We're solving for n. That means we've got to make the n happy. Is he happy? No, lots going on. He's being multiplied by 3, and there's a plus 6p. What's the rule? Which one do I take care of first, the 3 or the 6p? Why? Reverse order of operations. You go from the bottom up here. We're going to get rid of this plus 6p. So minus 6p, minus 6p. They're gone. Rewrite it. 3n equals 15 minus 6p. Right? Divide by 3, divide by 3. Guess what? N equals 15 minus 6p over 3. And we're done. Now, we're done except for one thing. I'm going to show you something, okay? And this is something you need to learn how to do right now because we're going to start doing this a lot more soon. So paying attention here. Something brand new. This right here is not actually done. 15 minus 6p divided by 3. Here's the deal. Is this not in parentheses? Isn't that secretly in parentheses here? Right? Okay, so really, it's 15 minus 6p, and then I'm dividing it all by 3, right? I can distribute that. I'm going to distribute that, right? Here's how you do it. Here's how you do it. You literally grab the 15 divided by 3 is, and then negative 6p divided by 3 is negative 2p. So really, it should be n equals 5 minus 2p. Does that make sense? Certainly looks a lot better. Agreed? I distributed it with division. Let me show you another one. Let's practice distributing with division right now. What if I have this? 4x plus 8 over 2. I'm going to show you one more time. I'm going to do one more for you so you can watch and see. I can distribute that too, right? It's this whole thing that's being divided by 2, right, Mr. Campbell? 4x divided by 2? 8 divided by 2 is plus 4. Does that make sense? That's how you distribute with division. Okay, so try another one. Try, let's go back up to this 4m minus 3n. No, hold on. I'm going to go 6n minus 3m equals 3. Okay, and I want you to solve for m. Okay, try that. All right, here we go. So you're watching. Here we go. Lined on the equal sign, getting the m by himself. He's being multiplied by negative 3, and there's a 6n. Which one am I going to get rid of? How am I going to get rid of that 6n? Plus 6n. Minus 6n. They're gone. Negative 3m equals 3 minus 6n. Read. Divide by negative 3. Divide by negative 3. Oops, this is an n. They're gone. M equals. Now, can I distribute anything here? What is 3 divided by negative 3? Negative 1. What is negative 6n divided by negative 3? Plus 2n. There we go. There it is. How many of you got that? M equals negative 1 plus 2n. Does it make sense? Does it? Does it? Oh. Okay. Oh, I'm going to show you something else. Nasty one here. Okay, ready? Here's a tough one. I'm going to show it to you. 3x minus 2y equals xy plus 5. And we're solving for x. I'm showing you this. You're not doing it. So just watch. Okay, ready? We're solving this for x. We have a problem here. What is that? There's x's on both sides. And it's ugly. This is not a pretty one. So let's get all the x's on one side then. Let's go minus xy. That gives us here 3x minus 2y minus xy equals 5. Let's clear this guy out of here because we're just trying to get the x's on the side, right? We're trying to get x's by himself. So we're going to go plus 2y. They're gone. So I have 3x minus xy equals 5 plus 2y. You see what I'm talking about? Can you all see what I did? All I do is I'm shifting things around. I just moved this guy over here and I moved this guy over here, right? I mean, that's not, you should all know you're allowed to do that, right? I can, right? As long as I subtract from both sides, we're good, right? Okay. Now the problem is this. Can I combine those two? Why not? Why can't I combine them? They're not like terms, right? They're not identical. One is an xy and the other one's just an x. I can't combine them. So watch what I'm allowed to do. I'm going to use the distributive property here to pull out something. Watch what I can do. I'm going to divide both sides by, well, actually, I'm not going to divide anything. I'm going to divide this right here. I'm going to pull out what I can from this. What can I pull out from this term and this term? X. So I'm going to pull out an x. We did this a little bit last year. And what I'm doing here is, in essence, dividing that thing by x, right? I'm pulling that x and shoving it out here. Okay, and so I'm going to divide this by x. What is 3x divided by x? 3 minus y. Now, I need you to look at this. Now, hold on. I'm going to go put that back so you can see what the deal is. Oh, I made a mistake on this, but I'll still finish it so you can see. Look, what is x times 3? What is x times negative y? Negative xy. Do you see what I've done here? Now that I've done that, and I have it equals 5 plus 2y, what can I do to now clear everything out and make the x be alone? What can I do? Is the x happy? Why not? What is wrong with the x? He's not alone. Who's with him? Who's with him? The 3 minus y. What's the 3 minus y doing to him? Multiplying him. So it's not hard just because it's ugly. What do I do then to get rid of that? What's the opposite of multiply by 3 minus y? Divide by 3 minus y. Divide by 3 minus y. They're gone. That leaves me with x equals 5 plus 2y over 3 minus y. We're done. We don't care. The x is happy. Yeah.
I'm a bit confused about the middle. So, what did that?
Hold on. If I asked you, how could I, if I was going to solve this for y, if I was going to get y alone here, what could I do? Look here, what could I do? If I wanted to get y by himself, just in this situation here, what could I do? I could divide the whole thing by y. I could factor this. I'm going to pull out what I can. What can I pull out of each one of these terms? A y. I'm going to pull him out. Right? I'm going to distribute him by dividing. I'm going to divide this by y, and I'm going to divide this by y. What is xy divided by y? What is 5y divided by y? I've now got y by himself. Does that make sense? Does that make sense? Yes. No, because I'm not doing anything. I'm not actually solving anything. When I go like this, if I had this and it said this equals 5 or this equals 12, all I'm doing is shuffling things over here. I'm not making it bigger or smaller. It would be like me doing this. Look, let's just say that I had this. Well, I'm going to go put this back and then I'll go like this. What about this? What if I have 7 equals 2x? Now watch. What if I did this? Did I need to do anything to one side? Did I need to do anything to both sides? All I did was take that 7 and kind of break it apart. Does that make sense? All I'm doing with this right here is just breaking it apart. I'm not actually adding to it or taking away. I'm just kind of like on the pile of of our little scale here. All I'm doing is taking this and separating them. You know what I'm saying? Like I'm taking what's on there and moving it around. I'm not actually adding to or taking away from any of it. So what was it? X, y, plus 5 equals plus 5y. All I'm doing over here is just going, okay, I'm going to pull this apart and I'm going to divide this by y. Right? I'm not actually dividing it by y. I'm factoring it. We'll get to this. We get to factoring much more later. Okay? Anyway. Try one for me. Try and do this one for me. See if you can do it. Just see d plus 5c equals 3d minus 1. And you're solving for d. Solve for d. Okay, do your best to try to move everything and then adjust and combine. And okay, you got it. For real. As up here. Here we go. First thing you do, line on the equal sign. I've got d, which I'm trying to solve for. I've got it on both sides of the equation. I got to get rid of that. Which one how am I going to do this? You know how to do this. What am I going to do? Get rid of the smaller one. Minus d, they're gone. 5c equals 2d minus 1. Okay, still trying to solve for d. What do I do here? Plus 1, 2d equals 5c plus 1. Now what? Divide by 2, d equals, and there it is, right? Whoa, there it is. We're done. What you could do here, and you'll have to get used to doing this, once we start dealing with the coordinate plane, taking this 5c plus 1 divided by 2, can I get rid of that 2 there? Can I use the distributive property here? I can. Watch what I can do if I wanted to. What is 5c divided by 2? 5 halves c plus 1/2. I could do that. I'm not saying you should. I'm saying you could do that. Do you see what I'm talking about there? I just distributed that 2 by dividing both. You see what I did? I'm telling you right now, I would like you to leave it like this. In this situation, you're leaving it like that. But you could put it like that. Okay? One last concept here that I want to show you is called dimensional analysis. And that is this. I'm going to show you how to do one, and then you're going to do a practice one. Okay, what if I have this? What if I walk 100, what if I drive 100 feet per second? Okay, and I want to know how fast that is in, when people say feet per second, when most people travel, what are we talking about? Miles per hour. In miles per hour. Does that make sense? If I'm traveling 100 feet per second, I want to know how fast that is in miles per hour. I showed you this last year once. I'm going to show you again. Pay close attention. There's a pretty cool way of doing this. I'm going to be converting two things. Okay, so let's set up our ratio. What is the first ratio we have? 100 feet per 1 second. Does that make sense? 100 feet per 1 second, right? Okay. And I'm going to set up a proportion now, and that equals, now here's the deal. Remember, we did this a little bit. Watch. I need to know about miles per hour, right? So I need to know about miles. What is the relationship between feet and miles? What's the relationship between feet and miles? 5,280 feet. Now look here. It's 5,280 feet for 1 mile. Now here's the deal. In the end here, I'm trying to get rid of feet. I don't want feet. I know that it's 100 feet per second. I want to have miles per hour. Agreed? In order for me to eliminate the word feet, I have to have one word feet on the top as a numerator, and I have to have one word feet on the bottom as a denominator. Then I can cancel them, right? I can cross them out. So is this written correctly then? No, what can I do? What can I do? 1 mile is 5,280 feet. I'm going to write another ratio, which makes the proportions the same. And that is seconds per hour. You see what I'm saying? I have to find out what's the relationship between seconds per hour. Well, how many seconds are there in a minute? How many minutes are there in an hour? What's 60 times 60? 3,600 seconds per hour. Okay, there's 3,600 seconds per hour. Am I going to put the seconds up here, or am I going to put the seconds down here? Why up? So I can cross them out. 3,600 seconds per 1 hour. Now let's start reducing here. Let's start reducing. I can get rid of the word feet and seconds. You see what that's going to leave me with, right? That's going to leave me with miles per hour. Agreed? Do you see how that works? I've eliminated the word seconds. I've eliminated the word feet. And all I have left for words is miles an hour. So we're in good shape here. But now we have to start reducing. 100, I can divide this by 10, making that 10, and making this 528. Does that make sense? Okay. I now need to go, okay, I'm going to divide this by 10 and divide this by 10, making this 52.8. What is 3,600, I need a calculator here, divided by 52.8. That's what I want. 3,600 divided by 52.8. 68 point, we'll just say 68 point what?
1818.
0.2 what? Miles per hour. Does that make sense? Miles per hour. Did you follow that? Yes? Well, I'm going to give you guys a simple one to try. Okay? This time I'm going to say we go 1.5. Okay, hold on. 150 feet per minute. How fast is that in miles per hour? Okay, that's what I want. You guys try that. Use dimensional analysis. 150 feet per minute. Oh, you need to write this stuff down. There's no way not to. And I want to know how far that is, how fast that is in miles per hour. Okay, so we have to set up our ratios. What do we have? What is the first thing we have? Feet per minute, and they want us to transfer it to miles per hour. So we have to make this into a couple of these babies. How many minutes are there in an hour? So do I want to go 60 minutes down here? And why not? You can't cross out minutes if they're both on the bottom. So you got to go 60 minutes in 1 hour. And then feet per is again, do I put 5,280 up here? Why not? Got to be able to have feet on the bottom, right? If feet's already on the top, then I got to put it on the bottom. 5,280 feet per 1 mile. What can I start eliminating here? Feet and feet, minutes and minutes. That leaves me with miles an hour. So anyway, what you can do is just this. What is 150 times 60? What is that?
That is 6,300.
6,300 over 5,280. What does that come out to when you divide that? What is 6,300 divided by 5,280? 1.1 what? 1.19. So 1.2 what? 1.2 miles per hour. Slow, but that should make some sense to you. All you have to do is, can you do some in your head? 150 feet per minute. That's half of a football field in a whole minute. That's you going pretty slow, right? 150 feet per minute is how fast you're walking. 150 feet, that's half football field. And that takes you a whole minute to do that. How fast are you walking? Very slow. So slow that in a whole hour at that speed, you would only go 1.2 miles. Right? Anyway. Okay. Let me give you your homework. Yep. I think you're okay.